we can only observe up to 3% of the universe, how can we calculate the total number of galaxies existing in the entire universe? The Milky Way is just a tiny galaxy amidst the vast universe filled with countless other galaxies. But if we had to make a reasonable guess, could we ever know how many galaxies the universe contains? It sounds simple at first, but in reality, this question is not that easy. The first issue is that even with the most powerful telescopes, we can still only observe an incredibly tiny portion of the universe. The observable universe is the portion of the universe from which light has had time to reach Earth during the universe's existence. Astrophysicist Kinoskare, currently engaged in community outreach at the European Space Agency, shares with Life Science magazine. The universe is 13.8 billion years old, yet its observable span extends beyond 13.8 billion light-years in every direction. That's because the universe is expanding, and the light emerged very early when the universe was much smaller. When we gaze at distant galaxies, we are essentially observing their past, because the light from them takes billions of years to traverse space and reach Earth. This means we can look back billions of years into the past, observe events that have occurred, and witness galaxies at different stages of their development. Moreover, the universe is continuously expanding, causing the distance between celestial objects to grow farther apart over time. This phenomenon causes light from very distant objects to shift toward the red end of the spectrum, known as redshift. Due to the expansion of the universe, the actual distance light has traveled from its emission until reaching us today is much greater than the age of the universe. Therefore, the observable universe currently has an estimated radius of about 46.5 billion light-years, forming a cosmic horizon. The light from that distant horizon hasn't yet reached where we stand, so the naked eye cannot see it. Pamela Elgay, a senior scientist at the Planetary Science Institute, said this number is far lower than even our most modest estimates for the entire universe. Here are the natural English translations of the given Vietnamese text. The second issue is that the number of galaxies is so vast that we can only estimate the total based on observations from small regions of the universe. He said, you need to pick a small patch of the sky, count everything in that patch, and then multiply it by the area of the entire sky. But even this needs limits, specifically how we define what a galaxy is. Noske also stated that besides giant galaxies with masses 10 times that of our Milky Way, the universe also contains countless other small galaxies. From galaxies with masses about 10 times lower than the Milky Way down to dwarf galaxies. At a certain stage, scientists need to determine the minimum mass of a galaxy to provide accurate estimates. If we set a certain mass threshold and try to make it a standard, such as 1 million times the mass of the Sun. From the dawn of the universe until now, an estimated 1 to 2 trillion galaxies exist in space. Scientists suggest that the number of galaxies in the early universe was greater than it is today, which is why galaxy estimates are often calculated as an average across different periods. Gay stated that those results came from the Hubble telescope. Currently, the James Webb Space Telescope is beginning to release these findings. Both telescopes are located near Earth, within the solar system, and are limited by factors within this system that make the sky background brightness more intense. However, we have had a spacecraft carrying a camera that has overcome all challenges in the solar system, the New Horizons probe. In 2021, a study used the camera system on the New Horizons spacecraft to measure the total amount of light from different regions of the sky, thereby estimating the number of galaxies needed to emit the measured amount of light. And then suddenly, when astronomers ventured beyond all sources of light pollution in the solar system, they realized, the universe doesn't need as many galaxies as we once thought. Therefore, according to their estimates, the observable universe contains around 200 billion galaxies, though this number could even reach 100 billion. Therefore, the number of galaxies in our observable universe is estimated to range from 100 billion to 2 trillion galaxies. To achieve this result, the research team used the LRRI camera on the New Horizons spacecraft to measure the amount of background light in the universe. This background light is the combined glow emitted by stars, galaxies, and other sources across the universe. By excluding light from identified sources, they could calculate the remaining amount of light, thereby deducing the number of galaxies needed to produce that light. This suggests that the universe may not be as uniform as we once thought. This could also impact current cosmological models and alter how we interpret the formation and evolution of galaxies. New Horizons was initially launched to study Pluto and the Kuiper Belt. Research has proven that this method can yield valuable data on various aspects of the universe. If you consider that to be the maximum 3% of the universe, you can multiply the number of galaxies within that range to estimate the total number of galaxies in the entire universe. If we observe that the universe is smaller than we thought, then the number of galaxies will also be fewer. But considering the fact that we don't truly know the size of the universe, those estimates become far too vague. If the universe is infinite, there must be countless galaxies. Advances in the field of telescopes and other observational instruments may alter this estimate in the future. However, the sheer number of galaxies in the observable universe alone is a vast treasure trove for us to study and explore. With billions of stars existing in each galaxy and countless planets orbiting them, the search for extraterrestrial life is the driving force that motivates scientists to continuously explore and research. Despite countless mysteries yet to be uncovered, the relentless expansion of our understanding of the universe remains one of humanity's most vital missions. That mysterious power makes the stars immortal. Could stars near the center of the Milky Way survive forever by harnessing energy from dark matter? Astronomers have just proposed a new hypothesis after observing mysterious light sources in the universe. Scientists have long believed that all stars will eventually fade and die. However, a recent study of the X cluster, located just 3 light-years from the center of the Milky Way, yielded opposite results. This star cluster is still very young compared to the other stars in the same region. And they are distinct from stars that migrated here after forming in other regions. What's even more surprising is that this place harbors stars of immense mass, far exceeding the normal range. The actual number of old stars is fewer than initially predicted. An important question arises. Are these strange stars absorbing dark matter and using it as fuel to sustain their activity? The research team led by astrophysicist Weiser Bellerin from the Kavli Institute for Particle Astrophysics concluded that the star formation model indicates that stars cannot form within a radius of 0.326 light-years from the central black hole, the very region where the X cluster of stars was discovered. Instead, stars must have formed elsewhere and then migrated toward the center of the galaxy. Conversely, observations indicate that the stars in this region are relatively young, with ages below or approximately 15 million years. This suggests that the stars likely formed in clusters or distinct groups. Dark matter is estimated to make up about 27% of the universe, but it still cannot be directly observed to this day. Astronomers can only detect its existence through the effects it has on surrounding objects. From the twinkling stars in the distant depths to the vast clusters of galaxies beyond measure. Although it cannot be observed directly, the gravitational influence of dark matter is undeniable. If the dark matter density of these stars is continuously replenished,